geometry folks, and welcome to today's lesson. You need your scientific calculator because we will be learning some new buttons today, a writing utensil, your foldable that we began making in class, and your notebook. Today we are going to begin our journey of trigonometry, or what is also known as trig. Have you ever wondered how we know what the distance is between Earth and Jupiter, or how tall Mount Everest is? Well, scientists have used trig to help them determine those answers. Other areas, in addition to astronomy, ecology, and of course math that use trig, would include biology, ecology, electrical engineering, physics, music, and carpentry. That's just to name a few. We will start our journey today learning what trig is and how it is used on basic triangles. As we continue our journey throughout this week, we will be working on application problems to see how trig is used in the real world. Trigonometry. It means measurements of triangle. We will be finding missing sides of triangles, and our focus will be on right triangles. We have been working with right triangles for 2 weeks now. However, we either learned about the special ones that have 45, 45, 90 triangles or 30, 60, 90 angles. Or we've also worked with triangles that only had one missing side, where we use the Pythagorean theorem. With trig, we have many opportunities to find missing parts of missing triangles where we only have one side given to us. So we will have 2 missing sides. That's pretty cool. So we will be working with some new buttons today on our calculators, and they are sine, cosine, and tangent. See if you can find those buttons on your calculator. If you have the calculator I have on my screen, you will find those buttons here. They are right here. There's sine, there's cosine, and there is tangent. So hopefully you can find those buttons. You also need to make sure that your calculator is in degree mode. You will see somewhere in your calculator that it'll say DEG. This calculator right now is in radians, RAD. So I don't want radians, I want degrees. And in order to change that, I would click this button. So now that we have identified the buttons and the mode that our calculators need to be in, let's begin by taking out our foldable that we started in class. We have 3 tabs labeled sine, cosine, and tangent. Remember, I had you label them SOH, CAH, and TOA. You will hear me refer to these as so, ka, toa. I refer to them quite often as that will help us remember what sine means. So, SOH, ka, CAH, toa, TOA. All right, now let's open the first tab that says sine and make your right triangle and label the angles as I have ABC and sides 5, 12, and 13. Remember, you can always pause the video if you need to. So we are going to begin with sine, which, if you remember, on the tab says SOH. SOH. So the sine of any acute angle, we're talking about acute angles, and remember, that is the symbol for angle, is equal to O over H, or opposite, and we're talking about the opposite side over the hypotenuse. So if we were going to make some ratios based on the triangle we have here, we could find an acute angle. Okay, angle A is our acute angle. And what I have my students do is always put a stick figure at the angle that I'm working on. It helps me remember where I'm at. So if I want to do the sine of angle A, I need to find the opposite side and the hypotenuse. In order to find the opposite side and the hypotenuse, I have to know what opposite means. So I have my stick figure here. Here is my angle. What is the side opposite of angle A? 5. So it would be 5 over the hypotenuse. And remember, the hypotenuse is always across from the 90-degree angle. And so that ratio of sine of angle A would be 5 over 13. Now, I can also do the other acute angle that is on my triangle. And that other acute angle happens to be, yes, you know it, B. So now I'm going to put myself at angle B. I can draw some pretty cool stick figures, but that's about it. So I'm at angle B, but now I need the opposite side to angle B. The opposite side of angle B would be 12. So the sine of angle B would be equal to 12 over the hypotenuse. And again, remember, the hypotenuse is always across from the 90-degree angle. So the two ratios that I can make of this triangle for sine of angle A and sine of angle B would be given 5 over 13 for sine of angle A, and sine of angle B would be 12 over 13. So now let's see if we can practice finding the missing side of a triangle using sine with one side given and the side that we're trying to find. So remember, we always place our stick figure, or our little guy, next to the angle in which we are working with. Remember, that helps us remember where we are. And now we're going to identify the sides of the triangle. The side that is labeled 7 is the opposite side because it's across from the angle 16. The side X is called the hypotenuse because it's across from the 90-degree angle. So to use the sine, I would say the sine of 16 degrees, I happen to know the angle now, it's 16 degrees, so I can plug that in, is equal to the ratio of the opposite side over the hypotenuse. Well, if I fill in the opposite over the hypotenuse, I have 7 over x. Now I have the sine of 16 equals 7 over x. I have one fraction. I can go ahead and make this a fraction as well. And now I can use cross multiplying because these are two fractions set equal to each other. Remember, that's called a proportion. So x times the sine of 16 would be x times the sine of 16. 1 times 7 would be 7. Now if you wanted to figure out what the sine of 16 was in your calculator, I'm just going to caution you here. You can either use the sine of 16 and make sure that you use what you have on your calculator. Or if you do want to write down what the sine of 16 is, you must make sure that you write down 4 decimal places. As if we round too early, then we will have some rounding errors and some errors at the end of our problem. So you can either say sine of 16 and leave it the sine of 16, or you can make it 0.2756. Now, I'm going to go ahead and divide by 0.2756 on both sides to solve for my x. You can also divide both sides by sine of 16. It does work both ways in your calculator. X would then be, as these would cancel, 7 divided by 0.2756, you would get 25.40. All right, that concludes our sine lesson. Let's go ahead and open our tab that says cosine. And again, remember, you can pause anytime you need to. We have our triangle here. Same triangle we began and started with sine. Our sides are labeled 5, 12, and 13. Our angles are A, B, and C. Now we're working with cosine. Well, so was SOH. Now we have ca, CA over H. That means any acute angle, okay, would be A over H, or adjacent side over the hypotenuse. And we haven't really talked about adjacent for a long time, probably since the beginning of September. So let's recall what adjacent means. Well, let's first find an acute angle. Let's go ahead and start with angle A again. Put your stick figure where you are at so we remember where we are. Adjacent means the side that's right next to angle A. Well, we have two sides that are right next to angle A. We have this side, which is a 12, and this side, which is 13. But remember, the 13 is across from the 90-degree angle. So that would always be our hypotenuse. So the one that's not our hypotenuse would be our adjacent side. That's the 12. So the cosine of angle A would equal 12, which is the adjacent side, over 13. Okay, now if I wanted to do the other angle and make a ratio of the other angle, acute angle, which is angle B, I put my stick figure at angle B. Adjacent, we have two. We have the 5 and the 13, but remember the 13 is the hypotenuse and that can't change. So the cosine of angle B would be 5 over 13. Okay, let's try a problem now. We put ourselves at angle 42. That's where we're working. We find our adjacent angle and we find our hypotenuse. Adjacent would be x, and the hypotenuse would be 18, because it's across from the 90-degree angle. So we set up our cosine of angle 42 is equal to a, which is x, over 18. Again, we can make the cosine of 42 a fraction, cosine of 42 over 1, and so now we have a proportion, cross multiply, 18 times the cosine of 42. If you don't type in the cosine of 42, you can go ahead and type in 0.7431 times 18 is equal to 1 times x, which is x, and you would get a value of 13.38. Okay? All right, let's go ahead and open our tab for tangent. Tangent, TOA, T-O-A. So it's the tangent of any acute angle is equal to the opposite side over the adjacent side. Well, we know what both of those are now. So now we have our same triangle. We're going to talk about angle A, putting myself at angle A, and I need the opposite side over the adjacent side to begin my ratio. So the tangent of angle A would equal opposite, that's 5, over adjacent, which would be 12. The tangent of angle B would be, if I'm here at angle B, opposite now will be 12, and adjacent would be my 5. So those would be the two trig ratios for tangent for my acute angles. So let's go ahead and do an example. Oh, here's my 24-degree angle. That's where I'm going to be standing. So I have the tangent of 24 is equal to O over H. We need to identify, O over A, excuse me. Didn't mean to write an H. O over A, we need to identify those letters on our triangle. If I'm standing here, the 15 is our A, and the X is our opposite. So we have the tangent of 24 is equal to X over 15. Make tangent 24 over 1 a fraction. Again, if you don't want to use tangent of 24 in your calculator, make sure that you do 4 decimal places. So that would be 0.4452 times 15, cross multiply there, and 1 times x would be x. 15 times 0.4452 would be 6.68. and that would be the side that's opposite of 24. All right, let's go ahead and look at a triangle and see if we can find both missing sides using SOHCAHTOA. So I'm going to write that down, SOHCAHTOA. Okay, you're going to put this in your notebook because you're not going to have room on your foldable. So again, I'm looking at angle 48, so I'm going to put myself at angle 48. All right, and I'm going to identify all the sides that I know. 8 is my adjacent side, correct? Yep. H would be my, you got it, the opposite side, and Y would be the hypotenuse. So if I'm looking at this, I have an A. So the only formula that I can use would be cosine or tangent. I can't use sine because I don't know what the opposite is and I don't know what the hypotenuse is. So I'm not going to use that ratio today. I'm going to use cosine and tangent. First of all, I'm going to go ahead and find x just because it's first in the alphabet. So if I want to find x, I am going to find the opposite, but I'm given the adjacent. Opposite is O, so I'm going to say the tangent of 48 degrees is equal to x over 8. Okay, so if I do that, I will then determine that I need to cross multiply. 8 times the tangent of 48 is 0.6691, and that is equal to 1x. And if I multiply that by 8, I would get 11.96. Oh, excuse me. I accidentally did cosine instead of tangent. I apologize for that. All right, so tangent on 48, excuse me, is 1.1106. Take that times 8, and I will get 8.88 is equal to x. So this side is 8.88. I apologize for that confusion. Okay, now I'm going to find my y, which is my cosine. So now I'm going to do cosine of 48, which equals adjacent, which is 8, over my hypotenuse, which is y. Make it a fraction. Do proportions, cross multiply and divide. That would be 8 equals y times the cosine of 48. Well, you know this one now is 0.6691. Okay, now I'm going to solve for y. Divide by 0.6691 on both sides. And I get y is equal to 11.96, which we already knew since I messed up on that other one. So we know both sides now. So we have used SOHCAHTOA to determine the two sides of the triangle. As we continue the journey, we will be focusing more on real-world applications, but hopefully for now, you understand how to use the trig functions and you're ready to come back to class and practice them. Thank you and have a great day.